Determine a possible equation for the graph of the following polynomials. Write your answer in factored form. Remember to consider end behavior, intercepts, and multiplicity. Use a leading coefficient of -1 or +1 as applicable. Okay, so starting with A. There's lots of different places you could begin here. One thing that is going to be helpful is identifying zeros. So I have a 0 at -2, at 0, and at +3. So already I know that my graph has to contain the portions x plus 2, just an x, and x plus x minus 3, as it goes in the opposite direction of the sign. Now, the next thing we should look at is degree, to make sure everything's multiplicity 1. So this particular function, if you'll notice, at all three of these points, the graph just passes right through the axis. It doesn't hang around, it doesn't bounce away. These are all multiplicity 1. So all I have is 3 zeros, they're all multiplicity 1. The total degree of this thing is 3, which is odd degree. Alright, but I'm starting in the negative, and I'm ending in the positive, and that right there is how your odd degree polynomials generally are. So this function right here works just fine. I'd have a positive coefficient out here. So this would be basically the answer. To polish it up, you might write it as like the x out front, and then the x plus 2, and then the x minus 3. And that's perfectly fine. Either way, it doesn't really make any difference as long as you have all of those pieces there. And also it says to write your answer in factored form, so there's no need to multiply this out. You can leave it just like it is. Alright, part B. The zeros that I have, it looks like at -1. So I'm going to start off there, so x plus 1. And then here at +2, so x minus 2. But if you'll notice, at -1, the graph comes down and bounces away. So that is a degree 2 0. At +2, it just passes right through, so that's degree 1. I don't need to change anything there. So the total degree should be 3, which it is. And since it's degree 3, that's odd. So if you'll notice, I'm starting in the positive direction and ending in the negative. And that is the opposite of what degree 3 polynomials generally do. Because think of the graph of x cubed. The graph of x cubed looks like this. Starts in the negative, ends in the positive. To reverse that, we need a coefficient that's negative out front. Right, for part C. Starting off with zeros, I've got a 0 here at -2, so x plus 2 is my factor. A 0 at 0 itself, so just x. So what I'll do is I'll just put the x right there. And at +1, so x minus 1. Now, at -2, the graph passes through the axis. That's degree 1. At 0, it touches the axis and bounces back away, which means that's going to be squared. And then at 1, it passes right through, so it's degree 1 again. The total degree of this thing is 4, which means normally in a degree 4 polynomial, the graph would start in the positive and end in the positive, which is exactly what's happening here. So we don't need to put a negative for the coefficient here because the end behavior already matches up. So that's a pretty good guess as to what the function here would be.